Good evening everyone, this is Swapna, Mathematics faculty from EDUHUNT IIT and NEET Academy. I hope everybody are doing well. In the last class, we have discussed about the concept of definition of relations and worksheet number 1 and 1A. So in the today's class, we are going to discuss the worksheet number 2 problems. Let's begin the session. So this is a first question of today's session. So read out the question. What did you understand? Please tell me. If A is a set, so given A is a set and it is expressed in the form of x is such that x square minus 5x plus 6 equal to 0. So what are the values of set A first of all? So try to factorize this. X square minus 2x minus 3x plus 6 equal to 0. X common, x minus 2 minus 3 common, x minus 2 equal to 0. So x minus 3 into x minus 2 equal to 0. So x is equal to 3 or x equal to 2. So these are the different values of x what we have got. Okay, so A is a set. You can write like you are having elements 3, 2 and B is a set which is already given, which is 2, 4. So these are the two elements which two sets A and B. Now what they were asking, and set C is also there, which is nothing but 4, 5. This is set C. So now in that case you need to find A cross B intersection C, right? A cross B intersection C. First of all, try to find out B intersection C. What is the value of B intersection C? The intersection, the common element is only 4. So now you need to find A cross B intersection C, which is nothing but A value is how much? 3, 2. So 3, 4, the elements are like, this is a Cartesian product, you will get order pairs 3, 4 and 2, 4. So what is the answer from this? 3, 4 and 2, 4. Option 1. Option 1. Understood this problem? Am I clear to everybody? Can I get back to next one? Alright. So what is my next question? A relation pi from C to R. C is nothing but a complex number. Okay. Any complex number, you will learn about complex number. Any complex number which is of the form A plus IB. Okay. A plus IB, and complex number is usually denoted with capital C. Okay, is defined by x pi to I, x related to y, if and only if when you will say the elements are there in this relation, if and only if modulus of x is equal to y. So, but you just tell me, how do you define this modulus function? Modulus function you people already know. Modulus function is nothing but root over x square plus y square. This is nothing but a modulus function, right? So how we will define modulus? If you want to remove this modulus, which is nothing but root over x square plus y square, this is a modulus function definition. Okay, so which one is correct? So let us go with option verification. First one is like 2 plus 3i. This is x value, right? This is x. Let us take this is x. So what is modulus of x then? 2 square plus y value is how much? 3. 3 square. So 2 square is 4 plus 3 square is 9. 4 plus 9 is root 13. But given here it is 13 itself, it is not root 13. So this is not being satisfied. So option 1 is being eliminated. Let us check with option 2. So 3 pi of minus 3. Let us take root over x square value 3 square. Square root will get cancelled. You will have only 3. But given it is equal to minus 3. This is not equal. So option 2 is also being eliminated, right? So next we will check with 1 plus I. Okay. What is 1 plus I? Root over 1 square plus 1 square. So root over 1 square is 1, 1 plus 1, 2. But given here is only 2. So this is root 2. Here we got is 2. So this is both are not related. So let us check with option 4. Okay. So what is the value of I square? What is the value of fourth option? I value is nothing but root 1 square. 1 square is 1. So I is related to 1. So which is option 4. So here in this bit you have to learn about the properties of complex number. Complex number is nothing but which is usually represented with a plus ib. In future you will learn more about this complex numbers. Okay, so any x, the modulus of x will be defined in the format of root over, if you have modulus of x equal to y. Here if I do the modulus of I is nothing but the coefficient of I is 1, that is treated as y. Okay, that is treated as y. So root over 1 square is 1. So 1 and 1 is being related. That is the reason the option 4 will be correct. Am I clear up to this? Can I get back to next one? Alright. So what is my next question here? Yes. So if the relation R is defined as A related to B, where A is 1, 2, 3, 4 and B is 1, 3, 5, defined by, so how we are defining relation on A and B? So x is less than y, where x is belong to A and y is belong to B. So R you have to define here, it should be x less than y, x belongs to A and y belongs to B. Okay, this is how x an element A లో ఉండాలి, y an element B లో ఉండాలి. ఇలాంటి ఒక రిలేషన్ ని మీరు క్రియేట్ చేసుకోవాలి. సో అప్పుడు ఏమొస్తుంది, సో మనకి యాక్చువల్లీ కార్టేసియన్ ప్రోడక్ట్ లో అయితే విల్ గెట్ 4 into 3 12 elements. Right, so from that elements no, do not need to write all the elements, that is a Cartesian product anyhow. మనం ఏం రాసుకోవాలి, రిలేషన్ రాసుకోవాలి. ఆ రిలేషన్ ఎలాంటి ఒక రిలేషన్ మనం క్రియేట్ చేయాలి, x y కన్నా చిన్నగా ఉండాలి. రైట్, సో లెట్ మీ టేక్ ఫస్ట్ 1 1 చిన్నగా ఉందా, నో, ఇట్ ఈస్ బీయింగ్ ఈక్వల్. నెక్స్ట్ 1 3 పాసిబుల్. రైట్, ద ఫస్ట్ ఈజ్ లైక్ 1 3 because x is less than y. సరిపోయిందా, x less than y. 1 3 clear. Next 1 5, it is also possible. 1 5. Next 2 1 not possible, x పెద్దగా ఉంది. 2 1 not possible. 2 3 possible. 2 3 possible. Next 2 5 is also possible. Next 3 1 no, not possible because x is greater. 3 3 not possible, equal. 3 5 possible. 3 5 possible. Next 4 1 not possible. 4 3 not possible. 4 5 is possible. So this is a relation. In all these cases, if you are observing that x is less than y, I am defining such type of relation. I am not writing here Cartesian product. If you are writing Cartesian product, you will get 12 elements in the set. But I am not writing Cartesian product. I am defining just relation over here. Okay. So how I am defining such relation? As per the condition, x should be less than y. So 1 3 1 5 2 3 2 5. Next 3 5 4 5. So if this is R, how we will define R inverse? This is a notation of R inverse. If you are, how to define R inverse? Inverse of R. For suppose in the R, if in the relation if you are having A comma B order pair such that A should be belongs to capital A and B should be belongs to capital B. This is a definition of order pair in the relation. How to find inverse? Inverse means the elements will get flip. Okay, A comma B will become null, B comma A. As usual, A belongs to A and B belongs to B. But this A comma B will flip as B comma A. So in that case, it will be like 3 comma 1. Next 5 comma 1. Next 3 comma 2. Next 5 comma 2. Next 5 comma 3. Next 4 comma 5. So now you have to do the composition of R circle R inverse. This is what you have to find out. R circle R inverse is nothing but it is a composition, means combination of, you have to write down the elements by creating a relation of these two R and R inverse relations. Okay, so how to do? 3 1 and 1 3. Can I write like 3 comma 3? First is like 3 comma 3. Next 5 comma 5 is also there, 5 1 and 1 5, which is nothing but 5 comma 5. So if you get these type of elements 3 3 5 5 is itself, then these elements will arrange in itself, which can be also written as 3 comma 5 and 5 comma 3. So option 3. Option 3. Am I clear up to this to everybody? Understood? Can I get back to next one? Okay. So what is my next question here? If the relation R, which is defined, R is mapping from A to B, where A is 1 2 3 and B is 1 3 5, is defined by R is a relation. How you are defining this relation? X comma y such that X is less than y, X belongs to capital A and Y belongs to capital B. As usual, like the previous question. So you have to define a relation, right? So how to define this relation? X should be less than y. Okay. So R you have to take. So let me take 1 comma 1 I cannot take. Next 1 comma 3 I can take. Next 1 comma 5 also I can take because X is less than y. 2 1 I cannot take. 2 3 I can take, and 2 5 also I can take. Next 3 1 3 3 3 5. So I have to take like 3. These are the elements of a relation which is being satisfied of the question. So what is the given answer? 1 3 1 5 2 3 2 5 and 3 5, which is option 1. Which is option 1. Am I clear with this question? Can I get back to next one? It's a kind of similar question to the previous one. Next comes this question. R is a relation. You are creating X comma Y such that X and Y both are natural numbers. Okay, that should satisfy this condition. X plus 3Y is equal to 12. Let me take X is equal to 1. So among these questions, if you observe, you are having numbers like 1, 2, 3, right? Other than 1, 2, 3, you don't have any elements. 1, 2, 3 and 6, 9. We'll consider these elements. It's just an option verification, okay? So let us take if X value is 1. What is the value of Y? 1 plus 3Y is equal to 12. 3Y is equal to 12 minus 1, which is how much? 11, correct? 11, yes. Next Y is equal to 11 upon 3. So this is not being satisfied, yes. So if you are considering X is equal to 1, that is not being satisfied. So next to check with X is equal to 2. What is the value of X equal to 2? You please check and tell me. What is the value of X equal to 2? If you are taking X equal to 2, what is the value I will get here? X is equal to 2. Y is not a natural number when you are considering X is equal to 1. So this may not be the option, right? So whenever you are taking 1 as a domain, you are not getting this. So I will eliminate this 1 and 4 options from this. 1 తీసుకుంటే మీకు అవుట్పుట్ 9 రావాలి, కానీ ఇక్కడ 9 రావడం లేదు. You are getting 11 by 3. That is not a natural number, so I should not take because it is a contradicting to the given question, right? So if I take X equal to 2, okay, let me take X is equal to 2. What I'll have? X equal to 2. 2 plus 3y is equal to 12. 3y is equal to 12 minus 2 is 10. Y is equal to 10 upon 3. No, this is also not being satisfied if you are considering X equal to 2. So let us check with X equal to 3. Let us check with X equal to 3. 3 plus 3y is equal to 12. This is also not being satisfied. 3 plus 3y is equal to 12. 3y is equal to 12 minus 9 is 3 is 9. Y is equal to 3. So 3 comma 3 is a possible option which is available in the third option. So from that only I can write this option 3 is correct, because 3 whenever you are giving here it is showing as output as 1, so option 2 is being eliminated. So కానీ ఈ రెండు ఆప్షన్స్ కూడా ఒకసారి చెక్ చేసి చూద్దాం. ఓకే, So next we'll put like x is equal to 6. So what is the value of x equal to 6? 6 plus 3y is equal to 12. 3y is equal to 6, y is equal to 2. So here you got 6 comma 2. Next is x value is equal to 9. 9 plus 3y is equal to 12. 3y is equal to 12 minus 9 is 3. Y is equal to 1. So 9 comma 1. So what are the elements you got here? R is equal to 6 comma 2. Next 3 comma 3. Next 9 comma 1. So this is R, right? But what they were asking you here, R inverse is asking us. So they were asking us to find out the value of R inverse. So you need to just flip the elements. If you are having A, B, you have to flip it and write like B comma A. That is a definition of inverse of relation, right? So R inverse like 2 comma 6 and 3 comma 3 and 1 comma 9, which is option 3. It is satisfied. I hope everybody got clear with this question. We'll move forward with the next one. So what is my next question? If A is x square minus 3x plus 2, try to write down the elements of A first. So x square minus 3x plus 2 is equal to 0. X square minus 2x minus x plus 2 is equal to 0. X minus 2 minus 1, if you take common, x minus 2. X minus 1 into x minus 2 equal to 0. We'll have x is equal to 1 or 2. So A is the set you are having elements like 1 comma 2, right? You are having elements 1 comma 2. And R is a universal relation on A. Universal relation in the sense you will have to write all the elements. A cross A is a universal relation of A, right? So whenever you are doing A cross A, how to do? 1 comma 1. Next you will have 2 comma 2. Next 1 comma 2 and 2 comma 1. So which is option 4. Am I clear with this question? Understood? So let's move forward to the next one. What is my next question? If R is a relation less than from A 1, 2, 3, 4, 5 to B 1 comma 4. So R you have to take such type of relation, X should be less than Y. So 1, 1 not possible, 1, 4 is possible, right? 1, 4 is possible. Next 2, 1 not possible. 2, 1 not possible. 2, 4 is possible. Yes, 2, 4 is possible. Next 3, 4 is possible. Yes, 3, 4 is also possible. Next 2, 1, 2, 4 is not possible. 3, 1 not possible. 3, 4 is possible. 4, 1, 4 is bigger. It is not possible. 4, 4 equal not possible. Obviously 5 is not possible. So X is less than Y because they gave you the condition it is or less than. So you have to create such type of relation, right? In that case they were asking you to find out R inverse. Very simple. 4, 1, flip the function, 4, 2 and 4, 3. So what is the answer? Option B, 4, 1, 4, 2 and 4, 3. Am I clear? Can I get back to next one? So with this we will wind up the class. I request you to do the problems on your own and create some more problems. So in the upcoming classes we will see some more problems related to relations. Thank you. Meanwhile, bye bye.